Good morning, class. Today what we're going to look at is how do we determine if a shape is a parallelogram. Before, we said if it's a parallelogram, there's 5 things that's true. If it's a parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Now we're wondering, what's the condition to make sure that it's a parallelogram? How can I look at a shape and say, oh yeah, that's definitely a parallelogram? The first 2 ways that I can tell if it's a parallelogram is by theorem 8.7 and 8.8. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So that's the opposite of what we had before. If I have, like in the diagram up there, the top left parallelogram, so this one right here, the opposite sides are congruent, which means it's a parallelogram automatically. Theorem 8.8 says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. In this scenario, you need both pairs being congruent. If you have only one pair, it's not enough. You need both pairs. Let's do example 1 here. Alright, so we have these 4 parallelograms. If I take a look at the upper left, I know only stuff about the length of the opposite sides. Well, according to the last theorem, I have basically 3 ways to say a parallelogram is a parallelogram. Both pairs of opposite sides are parallel. No, both pairs of opposite sides are congruent. Hold on a second, let's look. There we go. It's that one. Both pairs of opposite sides are congruent. This one is a parallelogram. And my reasoning might be theorem, I believe it's 7.8. Sorry, 8.7. This one over here, I look. First condition, both pairs of opposite sides are parallel. Now, that's what those symbols mean. So this is a parallelogram, which, by the way, sometimes we don't like to write the word, so we draw the shape parallelogram like that. And that literally means parallelogram. And my reasoning is because of definition of parallelograms. There we go. This one here, opposite sides being parallel. Nope. Opposite sides being congruent. Nope. Opposite angles being congruent. Yes, that's the one we're looking for here because the opposite angles are congruent. I would say parallel. Gotta write it correctly, but parallelogram. And I would say theorem, I believe it ends up being 8.8. Last one, opposite sides being parallel. I do have one, but I need both pairs. Opposite sides being congruent. Oh, I again have one set of opposite sides being congruent, but I need both pairs. Opposite angles being congruent. I don't know that. So in this case, not enough info. If I was given a little bit more, I might be able to say yes or no, but not enough information. So, these 3 are the ones that we've done before. Theorem 8.7, opposite sides have to be congruent, causing it to be a parallelogram. Definition of parallelogram. And theorem 8.8, opposite angles have to be congruent to make it a parallelogram. Example 2 will come after the next 2 theorems. Theorem 8.9 is if one pair of opposite sides of a quadrilateral are congruent and parallel. So if we look back at this one that I did before, it says one pair of opposite sides of a quadrilateral are congruent and parallel. Well, I have one set being parallel and one set being congruent. But the way it's phrased, this still would not be enough information. It would have to have the form where both the same side is both congruent and parallel. So theorem 8.9 only works for one like this, where this is 8, and this set is parallel. This I could say, without a shadow of a doubt, parallelogram, theorem 8.9. This is still not enough information because they don't match up. Alright, so theorem 8.9, if I see this, one set of opposite sides being both parallel and congruent, then that shape is a parallelogram. Theorem 8.10 now takes a look at the diagonals. Now we're not looking at the sides or the angles. We're going to look at the diagonals. And if I think back to the last section, I said if it's a parallelogram, the diagonals bisect each other. And it just so happens that if I had a shape with the diagonals bisecting each other, like this one, where both sets of diagonals are cut in half, then I know that without a shadow of a doubt that this shape has to be a parallelogram. So if the diagonals bisect each other, parallelogram. So there's 5 ways to show something as a parallelogram. First of all, use the definition of it. Opposite sides being parallel. Opposite sides being congruent, both pairs. Both pairs of opposite angles being congruent. One pair of opposite sides being congruent and parallel. And last but not least, the diagonals bisect each other. These are the 5 ways to show that a quadrilateral is a parallelogram. So now I give you 4 new shapes, and I say, determine if this shape is a parallelogram. Explain. It could be any of the 5 reasons I said. All you have to do is figure out if it is not. Alright, so these are the 4 shapes I was given. Let's just start in the upper left. Now, what I see is diagonals. I see that the diagonals are cut in half by each other. Whoa. The diagonals are cut into half by each other. Well, that means I know without a shadow of a doubt that this shape has to be a parallelogram because there's a theorem called 8.10. If a quadrilateral has its diagonals bisecting each other, that shape has to be a parallelogram. That's what that theorem says. Has to be. No way around it. This one over here. I see diagonals. I haven't given length. I only know that one of them is bisected. I don't think that's enough. Alright, let's move on. Sides. I have one pair of opposite sides being congruent. Again, not enough. I need both pairs. Or that side also being parallel. I just don't think I'm given enough information here. None of the ways match. So I put not enough info. Of course, I'd spell not enough, correct. But not enough information. Let's look at the next one. I see a set of sides being congruent and parallel. Wait. One set of sides being congruent and parallel? Yeah, that's another condition that I know by heart. And this one is because of theorem 8.9. If one pair of opposite sides is both congruent and parallel, the shape's a parallelogram. Done. I look here. I have one set of sides being congruent, another set of sides being parallel. While I'd be tempted to say yes, this is still that not enough information. It's not matching up just right. So it's not enough info because it's not the same pair. If it was the same pair, like this one here, if it was the same pair of sides being congruent and parallel, it would work. But seeing it's a different pair, I'm not sure. It could be parallelogram. It could also be another shape called trapezoid. So not enough information. So the 2 on the right are not enough info. The 2 on the left are because of the 2 new theorems. Alright, so a lot of this section and chapter will be determining whether or not something's a parallelogram. That's just the nature of what we're dealing with. Other questions I might ask you would be, what value of x will make it a parallelogram? So for instance, in these 4 shapes, I now am not asking is it a parallelogram? I'm asking, when could it be a parallelogram? What condition needs to be satisfied for it to be a parallelogram? Maybe it's already enough information and we don't have to do any more. Maybe I have to do a little bit of math to figure it out. But let's redraw it first. Alright, so let's look in the upper left one first. I'm given side lengths. I already know that one set of side lengths equal each other and is congruent by consequence. So I bet if I had the other side also being congruent, that would be that theorem, I believe it's 8.7, where it says if the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So all I have to do is get this condition to be true. If 2x minus 4 equals 5x minus 16, this is a parallelogram. Oh, so really all I need to do is solve for x. For what value of x is a quadrilateral parallelogram? Well, alright, so let's solve. Let's subtract 2x from both sides. Negative 4 equals 3x minus 16. Let's add 16 to both sides. I get 3x to be equal to 12. Divide by 3 to both sides. I get x to be 4. And there we go. Yep, that's the value that will make it the same. When I plug 4 in, I get 20 minus 16. This length is 4. When I plug 4 in, I get 8 minus 4, which is 4. It just so happened that that also ended up being the same one. So yeah, now that shape is for sure a parallelogram only when x is 4. If I look at this next one, I already have one pair of diagonals bisected. Wait, so then all I need is another pair of sides being bisected, and this is a parallelogram. Well, that's 2x and that's 6, so 2x has to equal 6. Okay, so x is 3. Divide by 2. Alright, down here. Oh, I already have one set of opposite angles being congruent. So all I need is a second set of angles being congruent, and I have a parallelogram. So I need 120 to be equal to 8x minus 8. And then I have a parallelogram. Well, add 8 to both sides, I get 8x to be 128. Divide by 8 to both sides, and I get 116? 16. That's the value that would make that one a parallelogram, because the opposite angles would be congruent. And last but not least, this one. The one pair of sides is both parallel, so I also need to get the one set of sides being congruent. So 11 has to be equal to 5x minus 4. Add 4 to both sides, 5x equals 15. Divide by 5 to both sides, x equals 3. Awesome. There we go. These are the values of x that would make these parallelograms. Alright, this is the main bulk of what you'll see. Now there is one particularly tough homework problem. And for that problem, I'm going to need a coordinate grid. So I'm going to quickly turn on my projector here. The next question reads, the vertices of quadrilateral ABCD are given. Draw quadrilateral ABCD in a coordinate plane and show that it is a parallelogram. So I have to show that this is a parallelogram. I have multiple ways I could do this. I could say, alright, what I'm going to try to do is show that the opposite sides are congruent. So I'd be using the distance formula. I could also be trying to show that the opposite sides are parallel. So I'd be using the slope formula. I have my options here. So let's look. A is 0, 1. So 0, 1, this is A. The next point is 4, 4. So 4, 4, right about here. The next point is 12, 4. Alright, so I'm going to have to extend this a little bit. 12, 4. And the last point is 8, 1. Alright, so I've drawn it. And now all I have to do is show that it is a parallelogram. Now I have three options here. First, I can find the slope of each side. And if I had this slope equal this slope, and this slope equals this slope, parallel. Both sets would be. And that would mean it's a parallelogram. Another option would be to show that this length and this length are the same, this length and this length are the same. So opposite sides are congruent, thus parallelogram. The last way is I want to say the best, and it's kind of the most elegant way. It's the one that makes the most sense to me. Now, I like horizontal lines. Why? Because the distance formula is easy for the horizontal lines. Because the length of this segment here is just what I count to the right. So 4 to 12. It stayed at the same spot horizontally, vertically. So that means 4 to 12, I take 12 minus 4. This is 8 long. I can show a little bit of work. 12 minus 4. I can do the same thing down here. It's the same spot vertically. So 0 and 8. So I do 8 minus 0, which would be 8. I have lengths being equal. So I've already shown that length of segment BC and length of segment AD are equal. Alright. Now, I have an option. Seeing I've shown that these lengths are equal, I could do the same thing here, distance formula here, distance formula here. But there's quite a bit of room to mess up that distance formula. So what I would probably rather do is show that the slopes are the same. I would show that the slope of segment BC, well, the slope formula, if I remember correctly, is y2 minus y1 over x2 minus x1. And if I plug it in, y2, I'm going to have x2, y2 be over here, x1, y1 be over here? So y2 minus y1, well, that's 4 minus 4. On bottom, x2 minus x1 is 12 minus 4. And when I simplify this a little bit further, slope of BC is equal to 0 over 8, or 0. The next one, let's do the slope of AD. That would equal, again, y2 minus y1. I'm going to call this over here y2, y1. Sorry, x2, y2, x1, y1. So y2, y1, x2, x1. So again, when I simplify this a little bit further, I find out that it's going to be 0 over 8, which the slope of this would be 0. I've just shown that the slopes are the same. So I've just shown that segment BC is parallel to segment AD because they have the same slope. And now that I have both those conditions being met, A, B, C, D is a parallelogram by theorem. I think it ended up being 8.10. No. Sorry, my bad. I believe it's 8.9. So you might be using the distance formula showing sides are congruent. You might be using slope formula to show sides are parallel. You have three choices. You can use the distance formula 4 times and show that the opposite sides are congruent. You could use the slope formula 4 times and show that the opposite sides are parallel. Or you could do this. You take one set of sides and you show that it's both congruent and parallel, having the same slope. If you have a set of these being horizontal or a set of these being vertical, that's the one I would choose because finding the distance of vertical or horizontal is pretty straightforward. And honestly, would you really have needed to show this much work to say, hey, this is a horizontal line? Probably not. But it's a lot easier just to show the work here to say, hey, this is parallelogram because the opposite side is both parallel and congruent. I believe this is all I have for you today. It is. So, till next time.